Record. Okay, we can go, guys. Passaic County Technical Institute in New Jersey this morning, and we're doing the ice from Regolith project.
Yep. So, I mean, we could just start off by showing you the progress we made so far by doing you guys a quick test.
But introduce yourselves.
All right, sorry. I'm Aaliyah Nazim.
My name is Shazman Khan.
My name is Gavin Yip.
And I'm Colin Smith.
Awesome. And thank you for wearing those masks.
Yep, safety first.
Can you hear them through this?
Yep,
Okay.
we seem to be all right.
Yeah, if you can see, I can only move it so.
Yeah.
We're trying to make this as easy as we can to you. Maybe that works. Okay.
Yep, that looks good.
Flo, could you turn off your mic?
Yep.
Easily, but all of our ABS is going to the top and coming out. You guys explain.
Coming out of this gray pipe.
Okay, let's stop on that and let's explain now what's going on. Show them, you can show them this one. Show it to the camera.
You guys see that? We got mostly our ABS. It's separated from the Regolith mixture.
That's amazing. Now, and I could not tell what your mechanism was for separation. What did you do there?
So we have motors on the
You can
side.
take your mask off.
We have motors on the side which make it vibrate. So any of the ABS or ice would float to the top. And then since it's near the surface, we would go through this tube right here since it's at the top. And if you keep the level consistent, then any ice on the top would just fall out.
Yeah. So basically what we have is that there's a funnel at the bottom, and that funnel would supposedly push out all the cement. And because of the vibration, the ice is supposed to go on the top. Since it goes on the top, it goes out there, and this is where we input all
This allows
Regolith and the
us
cement.
to continuously fill it up with Regolith without having to stop, because since both the Regolith and the ice are being controlled at the same time, just keep going nonstop.
So you're trickling in regolith and ice, and if you can keep that fairly consistent, then you will get a consistent pouring out of ice. Is that correct?
Yes.
The only issue we're finding is if we end up accidentally pouring too much or pouring like above, like we marked off a line around here. If we end up filling over that line, then some of the Regolith starts to mix in with the ice. But if we keep it fairly around that level, we find that we only get ice.
That is terrific. Okay, now that's really exciting. I couldn't quite tell how big of pieces of ABS that you're using. What kind of sizes are you looking at there?
I think it's around like 3 millimeters.
Okay. So is this filament that you had cut up, or where did you get the ABS from?
We actually we found ABS sold in pellet form, and we got it with that, so we don't have to cut up anything. It's like, yeah.
Okay, and that's perfectly fine. So what do you think you want to do next?
So first of all, like the issue we had during our first test was that the legs were a bit unstable. So, and it kind of required people to hold on to it. So that's like one of our first steps we're gonna fix. We ended up attaching like a few extra sticks to keep it stable for the test that we did now. But we're gonna fix that, and we're gonna also try to add like a hinge to make it foldable so we could like have compact shit in it. And another thing is, for the bottom funnel, we're controlling it with our finger or like duct tape. but we're thinking of replacing it with some sort of valve so that way we could control the amount of regolith that comes out. What we were trying to figure out is if we could use some sort of sensor to detect the level of regolith that's in the inside the main part of the container. That way it could adjust the valve and release as much regolith based on what we need so it keeps meeting that level.
I like that idea. I think you should look for a butterfly valve.
Yeah,
That's
that's
what-
what. Yep, that is
that's
exactly what
exactly
we're
what
doing. Yep.
It sounds like you're very smart. I like what you're doing. Tell me about your motors. Looks like you've got 2 of them on either side. Is that correct?
Yep.
Yes.
Yeah, so
How did
We
you
have-
arrange that?
so we have 2 motors on either side, and they have centric weights on them, which make it like vibrate. And they're
Uh-huh.
brushless, so they work better in like cold environments rather than like brush motors. And we can control the speed over there. So they can like we can control how they vibrate and the frequencies. So if like we wanted to go towards one direction, we can turn up one motor and lower the other and make it.
Oh, so by having 2 motors, you can change that vibration even more, can't you?
Yep, and we could
Yes.
adjust where the vibration is located based on that. We have 2 potentiometers set up to each motor, so that way we could adjust either. So we can move the ice in a certain direction. So if it's like leaning towards the wrong side, we can get it more centered.
We have control switches pretty much. Yep.
These are the stupid kids in my class.
Oh, incredible. Okay, I'm really excited. I think you've got something very exciting there, team. Can you show me one of your motors? Because I'm interested in how you did your setup.
Get it closer.
Yeah, a little bit closer is all. Can you turn one on?
Yeah.
Uh-huh. Okay. It's funny. It's funny because I can't hear it. I'm not sure it's in a range that your microphone doesn't pick it up. It's okay.
It's actually pretty loud.
Yeah, it's pretty loud.
That must be why. Okay. Now, tell me about the hopper that you've made there. That's an interesting shaped hopper that you've built.
So to keep it at the right level, we can like release it at different times to make sure that it's at the level so it doesn't go over and no cement makes it into the container. But our problem is we don't know how to control the valve and keep it at that level and detect when to turn on or open or close the valve.
Okay. I think that you guys are on a good path. Something that might make it easier is to look on the internet for I think you could probably do a search for something like a food hopper. I'm just trying to get you some words that might show you what already exists. And it might give you some ideas as to what to work with. But I like what you've done. I think it's very smart the way you've put it together. And I like how you've put together your own motors and vibrators. I think that that's terrific. The fact that you are getting some ice or some ABS to fall out all on its own is terrific. And I think you've got a great path there. Excellent job, team.
We also want to show you, we did do a full-fledged test with a large substance, and we want to show you the results of that.
So like
Bring it up a little bit. Tilt the camera down. You can see that it's mainly the ABS that we got in there.
The issue we're finding is like they said to use in the mixture to use like different rock size, like different pebbles and like gravel. Those also come up with the ice. Like we don't have any issue with regular like cement coming up with ice, but we have rocks that come up too.
Okay.
So
Why do you think that is?
that's
And it's the density of those bigger rocks, that's why. It's very
Well,
similar.
the density of your rocks are the same as the density of the dirt,
Yeah.
but still the rocks come to the top. Do you have any idea why?
maybe the
Concrete.
concrete is too compact, so it doesn't like go down as easily.
No, that's a good guess. And so, just so you know, this was a physics problem for a very long time, and it was only solved in like about 20 years ago. Okay, so and you can look it up. It's in reference to how when you have rocks in the dirt, as the soil, if there's any kind of vibrations or anything like that, the smaller particles get underneath and lift up the rock. And so you're just doing it in a much faster fashion. It used to be like 1800s, people thought that rocks grew in the soil and that they would rise up. And the reason was they would see that year after year, rocks would lift up in their fields, and every year they had to pick up rocks. But what's happening is, as the soil shifts a little bit, smaller particles get underneath the rocks, even though they're the same density, and they lift those rocks up. Now you can look that up and understand that a little bit better, and it'll make a huge difference when you're talking to other engineers about why you're getting rocks in there. So how do you think you would separate out rocks from the ice?
The idea that we had is that in the container where all the regolith will go out, we were thinking of putting like a mesh on there, and that mesh would be sort of big enough to catch those big pebbles. That's what we're thinking.
And I think you're correct. And the smaller our ice particles are, the more realistic it's going to be. And it will, I think it will mean that your rocks will be that much easier to separate out. Okay. Yeah. Excellent job, team. I think you've got a terrific demonstration there of how this could work. Any other ideas of how this device might be used?
You mean for different other applications? Is that what you're saying?
Yeah. Are there any applications where this might be valuable on Earth?
Anytime you need to separate two like materials that are of different density.
Sure.
In a mining.
Yeah, maybe like a mining.
Like what? What do people like to mine?
Gold.
Diamonds.
Like ores, pretty much.
Oh, diamonds. There you go.
Yeah, that's what I'm saying.
So look at there is a real Earth value to this as well. So for example, gold is about 19 grams per cubic centimeter. So you can imagine how quickly you could separate it out with this kind of vibration, but it would go in the opposite direction, right? You'd be wanting to kick off the dirt and leave the gold behind. So excellent job, team. I'm very impressed.
We're glad you made it, because we were getting worried that you wouldn't get to see it. So I have a question. What is the composition of percent of APS to your soil in that mixture you're pouring in?
We basically just followed whatever the slideshow said, like 3 gallons of cement with I think it was like 4 cups of ABS. We try to follow that too.
Okay, that's great. I'm wondering if you changed the composition, how that would change your results too, because we don't know the composition, percent of ice to regolith. So you might want to vary it and see if there's any changes in that.
We tried doing small tests in which we would add more ABS or take out some ABS, and it's still pretty much had a pretty consistent result with taking out only ice.
Wow. So this is an amazing job you did there. I'm really impressed. And you did it in a very short amount of time too, which is real. Wow. You got your whole class helping you, right? So that was great work on all of that. So I really like it. And I'm thinking that on the moon, it would be upscaled, it would be way bigger, but I can see that operating on the South Pole, separating the ice from the regolith. I want you to think also about materials that would withstand those extreme temperatures. So that's, I don't know if you have a team working on that, researching what materials you could make that out of. And remember, the material cost is insignificant to the transportation, right? So make a really strong, good material. But you've solved the problem very beautifully. I'm very proud of you. And
Thank you.
let's see if Mike joined us, and so Mike is our hunch mentor, and he's the only one been in hunch longer than me, which I'm very pleased. He jumped on because I wasn't sure that if Glenn was coming. Mike, do you have any comments? You didn't get to see it. You're muted, Mike.
I was muted in two places. Sorry.
Yeah.
Sorry I didn't get to see it from the start, but very impressive. Very impressive. One thing I was thinking about on your valving, look at commercial valving systems, things like that. Also look at water jet, because water jets that actually cut metal mixed garnet with the water stream. So they have to control that flow. So I don't know what type of valving they do, but very impressive. And that's nice that y'all found the ABS pellets and you didn't have to do all that chopping and all that. I think they're used probably in plastic injection molding, something like that.
Yeah,
Good
no,
job.
I'm really pleased you found those pellets. I remember you said you had pellets and then you were going to grind them, and I said, nah, don't grind the pellets.
Like 40 pounds of pellets now.
Wow.
Pellets.
That's a lot of pellets.
And they will
It's a
get
lot of
everywhere.
pellets.
Mike, you were suggesting some kind of valving that's used on the water jet?
Yeah, water jet's actually the stream, the high pressure water comes through, and then you have on some hoppers on the side where the actual aggregate goes into to help in the cutting. So it's on a side hopper.
Okay.
So
And so you're saying as the water comes down,
Mhm.
they've got a hopper on the side, and they have to have some kind of a
That's
valve
right.
between. Now, that'd be a really tiny valve, but I
Right.
see what you're saying. That makes a lot of sense.
So I don't know if it's applicable, but perhaps. But I know
Okay.
that's one control system I'm familiar with on that.
Yeah. No, that's an interesting thought. I hadn't thought of that one.
mhm.
I was thinking of it kind of like when they're mixing different kind of foods
Yes.
for recipes and things like that in a factory. They might have like flour, sugar, salt or whatever, and each of them might be in a different hopper. And as they open those valves, it would go into that one section and get mixed up. Is that
Correct.
That's kind of what I was thinking about.
Yeah.
Okay. All right.
In my kitchen blender, to add something, it actually has a lid and then an opening on the lid that you can add others instead of like this with the thing coming from the side. You just pour it in on the top of the device.
But no, great job, guys. Very good presentation. Thank you.
Thank you.
Do you have any questions for us? I think there was one somebody was asking about.
Our main issue right now, we were hoping, is the detection of when to let the regolith go down from the bottom and let the ice go down from the other funnel, the sensor part of it. That's the only part that we have little to no idea of.
To make sure it stays at that
Yeah.
level. That's it.
Yeah.
Oh, you're muted.
You're muted. Go ahead.
But couldn't you do like a low water sensor? Isn't that kind of the same thing?
I don't know if it was.
So actually, I think you're saying it right, Mary. I think if you look at like the floater valve on a toilet, okay, there's a plastic ball and it rides on top of the water, and so here would be a similar, and so when the water gets low, it opens the valve and lets water in, right? And this would work the same way for you, because that floater ball, the floater, would sit on top, and when the when the quantity of dirt got low, it would come down, and you can open up a valve on the other side, and it would let in more regolith. And
Oh,
then as it came back up to the right height, so it would close the valve. And so we'd have as an opening and closing according to how it's draining out. Does that make sense?
Yeah.
Take a look at when you're at home, because you don't have the same ones at school. When you get home, take a look at the floater valve that's in your toilet, and I think that would work just fine for you. If you've ever lived on a farm, that's how. This is also the same way that they keep the water tanks for the cattle. That's how they make sure that they always have water in the tank for them. Is that okay?
Yeah.
Yep.
mhm,
Thank you.
Excellent job,
Yeah.
team. Now,
mhm.
it won't be exactly the same, but it'll work in the same principle, and you'll just have larger valves for opening and closing. Okay?
Mhm.
Excellent job, team. Very good.
Thank
Okay.
you.
And you can always ask us questions, just you can send them to Glenn and copy me, or copy me. I'll send them to Glenn, probably. All right. Well, thank you so much.
Thank you.
Thank you.
Thank you.
All right. So actually, Fairport might be ready, and we are 15 minutes early, so we could do Fairport while Billings Career Center gets set up, if that's all right. If you're ready, Fairport.
You guys ready?
Yeah, I think we're ready.
I believe we're ready, Flo.
Awesome. That will be great.
Okay. Hello, I'm Jackson. I am the team lead of the Ice from Regolith project here at FHS.
I'm Isis. I'm Boston.
And I'm Zoe.
So firstly, these are our two choices for our ice cement. So this is just ABS plastic shavings, and this is like yogurt cup shavings. Like we just cut them with some wires, and the reason why these two choices work is because their densities are around the same. So it's good to have an alternative and see how they work differently with the Regolith simulator.
And one of the things that we found out in our research is that Regolith is ferromagnetic. So we decided that we were going to try and incorporate a magnet in our design. And we were specifically talking about an electromagnet because with a normal magnet, you have to manually clean it. Whereas with the, give me 1 second, the electromagnet, once it picks it up, all I have to do is turn it off and it cleans itself, which would be very beneficial. That's what we're doing.
Okay, so this is our testing apparatus thing that we've been working on. Do you want to see a demonstration of it working? All right. So the stuff is vibrating at one of the best frequencies and amplitudes we've found to work. We've tested this a couple times and we've gotten pretty consistent results. So yeah.
Very good. And so you've got an electromagnet on the bottom that's turning on and off to give you the vibrations. Is that right?
No, so we're actually using a vibration generator that we had on hand. It's not the best because it doesn't actually give us frequency and amplitude readings. So we're trying to look for something that can actually measure that for us. But yeah, it's just a piston that's going up and down to vibrate the cup.
And that works fine. Can you change that speed?
Yes, we can.
Okay. And have you found any difference in how fast you make it go? In terms of how quickly it separates things?
Yeah. If it's going at a slower frequency, it doesn't separate at all or very fast. We're still working on narrowing it on that range that's good for it, but we're working on that and it'll really help to actually get numbers.
Okay, very good. And right now I see that you've just got a cup. Have you looked at other shapes of containers?
Yep, so we actually have a lot of containers back there that we're gonna test out. It took a while to get our whole apparatus thing set up to test with those, but we are gonna start with those really soon.
Excellent, excellent. Now, what about if you change materials for your container? Do you think that that would matter?
Yeah, it probably will. We have a metal thing that we were gonna hope to test soon. We just
Okay.
haven't quite come to it yet, so.
No, that sounds really good. Okay. Um, Now right now you've got it so it's vibrating from the bottom of it. Do you think there's a way to be able to vibrate from the side or from a different direction? Could that be helpful?
Yeah, that could be helpful. I was actually thinking of that and hoping to try it out. It will take a bit of work, but I think we can make it work, and we'll definitely try that.
Excellent, excellent. Okay. What do you think your next step is right now?
We got slideshow.
Share screen.
Yeah, go ahead.
So
Share screen. Click on the slideshow.
Yeah, you should be able to share your screen.
Yeah,
There you go.
Right now.
So
Okay.
slideshow. Could you go up to neutralization? So one thing that we sadly do not have a prototype for yet is neutralization. So during our research, we realized that regolith itself has an electrostatic charge, which is due to the solar winds impacting and causing to charge the regolith. This charge then leads to ice to possibly cling to the regolith, which makes it extremely difficult to separate. As well,
Wow.
any built-up static charge can seriously damage any electronics when discharged, which despite us trying to completely contain the regolith and not allow it to access the electronics or any moving parts, the electric static can once charged and then discharged, can jump and go through any barriers we have set up unless they are insulators.
Very good. Okay, keep going.
Our solution to that is removing the static electric charge by grounding by the regular.
Like grounding the regolith before we vibrate.
Thank you.
Right.
I can't English this morning.
That's okay.
That's
So
just fine. Keep going.
we've had two ways of doing that so far. Our first original one was a pipeline, which would just be a simple downwards pipe with a conductor and an insulator as seen in the drawing. But as of recently, we thought to use what's properly known as an Archimedes screw seen in the rotating picture.
Yeah.
Will
It's basically a Greek invention that pulls up water.
and is also now used modernly for sand, cement mix, and other stuff like that in formal factories and all that.
I think that's a really smart idea that you've got going there. Part of what I like is that, if you've got a metal Archimedes screw, you would be hopefully grounding all of that directly down. So that makes sense.
That is the intended plan, and it would also be able to, even if there was some sort of issue where the static electricity could leave the Archimedes screw, the grounding point would be from the base of the Archimedes screw, meaning all electrostatic charge will eventually go back to said Archimedes screw. One thing that we want to implement to the Archimedes screw to maximize contact between the regolith and the metal is having small little spikes or pikes coming up from the rotating base to kind of embed themselves into the regolith to remove more electrostatic charge than just no spikes.
I think that's a smart idea as well. Okay, now one thing that we've got going for us here is that once your rover starts driving around on the lunar surface, it's going to have essentially the same charge as the rest of the dirt. Does that make sense?
Yes.
And so even though there may be a static charge on everything, because it's on everything, it may not be a big effect. Okay. but I like your ideas of how to be able to make sure that we've got the same conduct or the same charge over everything. Now, one of the difficulties that there's no way for us to test with right now is how does that stuff change at the very low temperatures?
Yes.
As we're approaching, 0 Kelvin, and we're not going to get there, obviously, but as we get closer to it, there are some atoms and some materials that are going to become less conductive, or in some cases, a little bit more conductive. So I think it's very smart that you're thinking about this. Excellent job, team.
One thing that we also liked about the Archimedes screw is that since it is used to transport materials upwards, we can have some sort of system that basically becomes the input from outside of the rover or robot into the robot and into the sorted system.
I think you're exactly right. So part of what's happening is from the last class and your class, it starts me to thinking about what is the next step. Once you see how you want to separate your regolith from your plastic, it gives us the opportunity to start figuring out how do we want to scoop up the dirt and put it into your hopper or whatever it is. So you guys are going right along the correct path, and it makes a lot of sense the way you're saying this. Excellent job, team.
So, vibration.
Okay, so one more couple quick things with the vibration. So as we mentioned with the other things we were hoping to do, we were also hoping to test with, I know we mentioned different shapes of containers, but I wanted to try testing with like an upside down cone, just to see if we could separate them in different ways to get maybe the ice to go to the top or the bottom. So that's one cool thing. But I also just wanted to ask, do you have any ideas of anything we could use to measure the amplitude or frequency? I'm kind of stuck on what we could use.
Len, you're muted.
Okay.
Dave, Mike, do you have any thoughts on that?
No.
Mike, you're muted too.
Okay, I'll unmute.
Oh, no.
I'm not certain. I'm not sure if an RPM meter would be able to use it. I know there are digital meters like that. I know also in the early light shows, they actually used 2 mirrors basically to create all the patterns and everything. And they would just vary with potentiometers. They'd vary the input to the motors. And they'd have mirrors mounted to it, and the beams would go through that, and it'd create all the little sine waves and everything like that. So that would be one way to create maybe vibrations in 2 different directions. But voltage would be the only way I'd know that you could see what you were doing.
Okay, I've got a thought. I've got 2 different thoughts. One, go to your physics teacher and see if they have a calibrated stroboscope. Okay, something that flashes on and off, right? Another thing that you might check out is go to your music room and see if they might be able to help you with something. Dave, you got any thoughts for us?
Not right off the bat. I'm thinking about it.
So, I think if you've got a stroboscope, that would be a really easy way to get some of it. But it might even be easier if you've got something from the music room. I'm certain that they would have something for measuring pitch.
Yeah, I will definitely look into all those. Thank you.
So I just got on here a second ago. How are you generating these? What's your source?
Oh yeah, go back and show that again, team.
Okay.
That was really cool.
So this is what we have right now. We have a vibration generator thing that we already had in our physics department that we were using, and we're using it to vibrate this platform, which is then vibrating this cup, and all the material is inside there.
Oh, that's really cool.
Yeah, so this is it
Wow.
running. I don't know how well you can see it, but it's vibrating all the material around and everything's starting to separate. You just have to let it run for a bit.
That is cool. So is there not something on that machine that gives you hertz?
So it gives us the output current and the output voltage, but there's dials on the actual vibration generator for frequency and amplitude that we can't get readings from. It's just kind of a scale
I see.
high or
Okay.
low.
Okay. Hmm.
It's one of our reject devices from physics that we bought, but never used because it doesn't tell us the hertz. But it does give them the voltage and the current. I like the strobe idea, and I do have a strobe.
Yeah.
You can play with.
Could you try to contact the company that manufactured that? I mean,
Yeah.
even though there's not a readout on there, it has to somehow be calibrated.
Yeah, that's
I
a
would
very good idea.
think if you send an email to the company, they may be able to give you some suggestion on that.
All right, thank you.
And the music idea is really good because you can actually tune your instrument to the right frequencies, and it's an app on the phone even. You don't even have to buy anything anymore. So and like I play the violin, so every string has a different frequency, and the app will tell you what frequency you are on. Yeah, if it's an A, it's a certain frequency. If it's an E, it's a certain frequency. And the other thing that I thought that came to mind was when you might be in the negative 400 degrees, when you get that cold, electrons kind of like freeze. And it's a interesting phenomena called quantum pinning that you might be interested in looking up a little bit about, because you are at a really cold temperature at negative 400 degrees, and you would probably have some quantum pinning at that temperature.
Okay, yeah, we'll look into that.
Yeah, it's really an awesome thing. YouTube it, and you can see all kinds of amazing experiments done with the quantum pinning.
Yeah, sounds cool.
It is really cool. Okay, any questions, team? Or have you finished your slideshow?
We had one more thing to add. Yeah. It was just about the magnet design. Yeah. And just a concept.
So we had two thoughts for it. One was almost like a slider where the magnet was actually placed at a 45-degree angle from where the regolith and ice were being vibrated to pull the regolith up off the ice once it was separated. But then another thought we had was to put the magnet in the bottom of the container to then hold the regolith to the actual container after, and then move the ice from it so that they were separated.
Yeah, because that would be our phase 2 of separation after the vibration places the regolith on the bottom. And the problem with positioning the slider magnet on the top is that the regolith would pass through the ice and might get entangled with it again.
Yeah.
So that's why we kind of said probably to the bottom
of the
container.
Plus, we were thinking about using an electromagnet because, like I said before, it cleans itself, so we don't have to worry about that. But we were wondering what would be we still have to do some research on it, but what would be a good design for that, or what would be a good direction to go with that?
Yeah.
I'm a little lost on that. Mike, you got any thoughts?
No, I'm not sure. That's a good question, though.
Do me a favor. Write that up a little bit for me, and it'll make me think about it a little bit more. Just write it up as a question, and explain your situation a little bit better. And going through that might help me out a little bit. Does that make sense?
Yeah.
Okay. Any other thoughts?
One thing that we hope to improve on is that our proposed system at the moment is a batch-based system, which is less efficient, and we would prefer to eventually figure out a way to make it a continuous system like the previous group had, where we can constantly have an input of mixture and then as also have a constant output of ice and regolith.
And I think you can. And I think that part of the difficulty is coming up with the shape that allows for that kind of separation. And so part of it is the shape of of your your hopper, and also where you have the vibrations attached to. Are you vibrating the walls more? You vibrating the floor better, and also, um, you know, so you can imagine if I have pretend that if I've got one hopper and it only takes the top part off, and then I have like a trough. So this one vibrates, and then the ice comes off to the side. How does that what do you call it? How does the trough on the side that's taking it out, that might also be helpful in terms of how does it move to separate it out? Does that make sense?
Yeah.
But I think you guys are on a really good path. I look forward to seeing how you guys are gonna once you've separated it, now how do you cart it off to the other side? And I think it's just a matter of where do you place the holes, or the relief area for it to go, as well as how do you get rid of the regolith, and you have to be able to move both of them back off, and it's something you'll just have to kind of play with. But if you go back again to food preparation or something like that, it might give you some ideas there. In terms of like the mechanics of how they do the mixing in big industrial kitchens would make a big difference in terms of how it works for you guys as well. Think of it like as a factory, as opposed to a home kitchen, because that won't work at all the same. Okay.
Okay.
Excellent job, team. Keep this up.
Thank you.
Thank you.
Okay, I'm going to move into another room here. Sorry.
Okay, nice job. I love the demonstration and good work in using things you could find around the room. That was really cool. So you can always ask questions. Just copy your wonderful teacher. Okay. Thank you so much. And look up quantum pinning.
Yeah, I definitely will. It sounds really cool.
Yeah, and I like your shirt.
It's from PDR.
Comment on that, Flo. That was really smart.
Yeah. Okay, so we're going to move on now to Billings Career Center. Thank you,
Okay,
Fairport
thank you.
High School. Bye-bye.
Thank you.
Have a great week. Have a great week.
You too.
You too.
Thank you, Glenn, Mike, Flo.
Yep, you bet.
Flo, can you hear
Yes,
us?
I certainly can.
We're having some technical difficulties this morning. My main lecture computer isn't displaying anymore, and all of our microphone and our video and everything went through that. Our tech's in here right now. We're trying to hook the microphone up a different way. I need like 2 minutes, if that's okay, to see
Sure,
if we can
yeah.
do this here.
Yeah. Take your time.
Flo, and I'm gonna have to jump off. I apologize.
Okay. Well, thank you so much for jumping on, Mike. I really
Sure.
appreciate it. You're my
Oh, it was
go-to
great.
person.
No, it was wonderful. Thank you very
Okay.
much.
Well, thank
Bye.
you. Bye-bye. Have a great week, Mike.
You too.
Bye-bye. And I did see Stacy on for a while. So Glenn, are you able to join me this week or? Because I have.
Yeah, I should be here for a lot of them.
Okay, good, because I have every day, but my biggest day is Friday because everyone who couldn't fit in during the week is fit in on Friday. And that's because some schools meet every other week. And so if they couldn't meet the first week, then their projects were already gone. And so they came on Friday. In particular, Tri-County. They didn't meet last week, so they meet this week, but their projects were from last week.
Well, and I believe she's already started her mission, right?
Oh yeah, she's there until January. That will be so interesting.
December. I thought she was done in December.
Yeah, I don't think she's coming back to school until January, though.
And I think that's right. That's good.
So, and thank you for hosting. If they get back to you, the MSU students.
Remind me what that is.
The Montana State Space Consortium is coming to Johnson Space Center.
Yeah. I didn't see a message yet on.
Yeah. So the regular director is on I think a sabbatical. So this lady, and I know the regular one, but this lady is different. She's coming in to take the place of the regular director.
Good. Okay.
All right. Well, we see you now. We can't hear you.
Now can you hear us?
I hear you.
Hello. Awesome. You guys are up. I guess you're ready. I think we're good to go. We kind of got it. I think we're set. So we're gonna roll with this. So.
Okay, go for it.
Okay. Hello, my name's Vinny Burke, and this is Daniel K. And we chose the Ice from Regolith project. Yeah. So we're gonna pull up that.
Okay, PowerPoint. All right. I just need to share screen. I didn't get to practice this all beforehand and get it set up. Can you see our screen now?
Yep. Perfect.
All right. So our team we named Ice Baby. Sorry, Ice Baby, because we chose the Ice from Regolith project. Once we chose this project, we started writing everything down in our engineering journal, defining the problem, questions that we asked Flo, and then we also wrote down our brainstorming and everything we've done up to this point, including our prototypes and all of that.
And then also documented in our journal was our brainstorming. And so after we defined our problem, we went into brainstorming solutions. But due to some the small amount of time we had to generate concepts while we were brainstorming. And so the brainstorm is shown to the right on this PowerPoint. And we had a few ideas other than vibration, but we didn't end up pursuing them, like electrolysis and centrifugation and static electricity to collect the ice. And then, yeah.
All right. Our first problems were designing a pipe that we could kind of tile out using multiple different pipes depending on how long we needed them. We ended up eventually using a 4-inch long pipe, 3 inches wide and 2 inches tall. We made it so they fit together using kind of sort of fitment. We used 20% infill because we plan on being able to drill through them to let out some of the regolith.
And here are those parts right here, which on the left we have the pipe that'll just fit into the pipe with the supports. And so we have 2 of the supports, and then that will be connected to whatever our vibration technique is. which will then be connected to some kind of base.
So the vibration technique that we used was using an unbalanced motor. We used our teacher's brass tumbler to create the vibration, and then we attached our pipe to the top of it to get that vibration up to then our mixture that would sift out, I guess, the ice separate from the regolith and gravel.
We're hoping in the future that we will use a hobby motor, because the hobby motor will be a variable speed unbalanced motor, whereas this brass tumbler is not. And one of the main problems by using this brass tumbler was to mount our design on top of it, but we'll get to that in a second.
We created our ice mixture. At first, we started cutting 1 to 2 millimeter cuts of ABS plastic. And after cutting for 8 hours with 2 people cutting, we had about a cup, and we needed 4 cups to create our desired mixture. And so then after that, we decided it would take too long to try to get all of that. So we started looking for other materials that would have a similar density and be more accessible. So we ended up using a kind of corn that has a very similar density, and we had 4 cups of.
Hey, you guys are very smart. Good job.
Is that like a corn meal?
It's a corn brass tumbler media. And so it was actually in our brass tumbler when we got it, and when we measured it out, it ended up being almost the same density.
Very good. The closer to the density of ice, the better you're going to be. Okay? Excellent job, team.
And so here's our first prototype. We created this in Autodesk Inventor, and then we also created the lid so we can show it. But the basic idea is to pour the mixture at the back, and it'll be on a slight tilt downward. And as it goes down, our regolith will drop out the bottom and back, and leaving it at the end of the pipe just ice falling out, or at least mostly ice. The back sifter, which will be used to sort out some of the bigger particles, didn't print right, and we don't have bigger particles currently in our mixture, so we didn't put it in our test.
And this is our first assembled prototype. It is the pipe that's attached to our brass tumbler. And we don't plan on this being our final project piece, but it did work for our first use.
You guys ready for the video?
Do you have any video of that? I'd love to see.
Yeah, sure. You want to do it next?
You want to skip to the video now?
Yeah, and then we'll come.
Yeah, let me see that.
And then
So that's all corn that's coming out there, or plastic?
yeah, well, that's our corn media.
So I'm just going to add it. So the corn media that they had is what's designed to tumble brass, to shine the brass. And it's the same exact size as that ABS they were cutting up right there. And the density matches up. But they'll try it with ABS. They just didn't want to use up their mixture that took so long to cut on this first test.
So I do not have a preference for what the material is, as long as it matches the density that you're looking for. So I think you guys are doing a terrific job. I like that you switched to something different that was easier and worked better for you. Good job, team.
So when
I was
when you had
skeptical.
that running, was that trough horizontal or is it angled at all?
You want me to go back to the video or?
The half pipe on top?
Yeah.
So it's not angled at all because when we were printing it, we couldn't get it to do an accurate angle downward. So we're hoping to put a little measuring block on the bottom of the brass tumbler. That way we can angle the entire system downward. And now it wasn't down. I think it had a 1 millimeter lift or something. It was a very small lift in the back.
But that's actually probably pretty good. I mean, when you think about it, because you're getting that lighter stuff rising to the top, and if it actually has to, go up, even less than a 1% slope, that's going to help to keep that concrete mix from migrating out as well. That's actually really cool, guys. I'm
That looks
impressed.
really good. I'm impressed. Now, what happens if there's gravel inside along with that?
We haven't tested that yet, but we're hoping that we have a piece here.
You gotta bring it up here to show your little, show how the camera.
We have a piece here that we're gonna fit almost like a sifter into, so that the larger pieces of gravel will then be stopped and then pushed out the back, and then leaving just the cement and ice mixture.
Okay. And how do you think you're going to separate out the cement from the ice?
So our current plan is that on our half pipe, the cement seemed to gather in the back of the system. And so we're gonna have a drop out the back, and so that right when you pour it in, it'll vibrate and hopefully the cement will be at the bottom. And then it'll drop the cement out the back. And then as it goes down the pipe, we're hoping to have more smaller holes, because it seemed like in our test that the cement seemed to stick to the right wall and the ice seemed to stick to the left wall, which was very
That's
odd.
interesting.
And so we want to explore and see if we can use that to our advantage.
Okay. Why do you think one has a preference for one side or the other?
I think it could be just because of the way that it 3D printed. I think that one side could be slightly more angled, and so that heavier cement goes to that one side, and then all of the corn raises and goes to the upper left.
That's interesting. You might also look at just how if you take your structure and shift it to the left or shift it to the right on your vibration tool, that may also give you some kind of a preferential there as well, because you might get one side that's kind of wagging a little bit harder than the opposite side, and it might just be how it's placed on there. Does that make sense?
Yeah. Okay.
Okay. Very smart, team. I love what you're doing. What do you think your next step is right now?
I think currently our next step is to work on dropping the actual regolith out and then collecting it. And then hopefully if making a system where we can collect the regolith and then rerun it through the system, that way we can collect any ice that may have fallen out as well.
Okay. I'm impressed. Keep this up, team. Very good.
Agreed. That's really cool, guys.
And
Any other thoughts?
Well, I like your whole design and that you're using a tumbler. And actually, I know Mr. Wagner in the machine shop has a really good tumbler because he made parts for us and he was using a tumbler all the time. So you could always go down there and look at his tumbler.
Okay.
It's big. It's not little. Now, do you have any questions for us?
Do you have any questions, Tim?
I don't think so.
I don't, well, actually, hold on. No, I don't think so.
Okay. Dan and Vinny. Good
Do you have
job.
any other comments, Dave?
Well, I'm still intrigued by the notion that you're getting a separation between your cement in your corn one side to the other. And you might be onto something. It might be just some little anomaly in your print, but you could probably test that. I mean, you could probably create some very thin little shims or something that you could just lay, you'd have to tape them down or something. Maybe even a couple of just layers of duct tape or something like that that you could shape and slope accordingly and see if in fact that increases or has any effect on this stuff separating, because that would be very beneficial if you can induce this to work that way and then change the design of your trough a little bit accordingly. You could that could be a great asset. So it would be worth playing around with a little bit, right?
Yeah, I really like, it happened by accident, maybe, that it wasn't level, but take a level and see it if it isn't level. If you have a little one that will fit in there, and see if it isn't level. And that might be, it's just a physical attribute of the pipe, but it could be a very important physical attribute of that pipe.
Just because David mentioned it, imagine if you take, I think you've got 4 legs on that thing. If you put some screws at the bottom of your legs, and you could adjust it to get different heights or something like that as well, and that would make it very tunable if you find that that's part of the deal. So very smart team. I like where you
That's
guys
a good
are
way to describe it. Yeah, you may be able to fine tune this thing with very small adjustments.
Yeah, you can even put a little piece of cardboard under it to see if it makes a big difference. You got it already printed. See if that slope makes a difference in the ice going to one side, because that was a very important observation you made, keen observation. And thank you for making that video, because that really did show a great separation. All right. All right. Well, you can always ask questions, that. So thank you so much.
Yeah.
All right. So the next team is Jackson Hole, and they're 15 minutes away.
Thanks, guys.
Thank you so much. Have a great week.
You too.
Great job. And the sound worked perfectly, and the picture too.
I'm going to take a break for a minute here, Flo.
Yeah,
I'll be right back.
You got 15 minutes before Jackson Hole comes.
Okay.
Thank you,
You're
Glenn.
going to keep this active, Flo?
Yeah, I'm going to keep it active.
All right, I'm going to do the same thing.
Yeah, me too. We only have Jackson Hole and Glenelg.
You could, I'd say just start it now, and then you could just go in there for the last few minutes or something, or you could go into the study room at the library. That would be my other suggestion.
We could go to the library. Yeah, let's go do that.
I know they're expecting you guys in 2 minutes, so try to do it.
Yeah, that's all right. Go to the library or wherever you want to go.
I wonder if Holden's actually going to show up. Be surprised.
Yeah. I'm pretty sure he's gone.
Are there people in all the pods though? Yeah.
You don't think Holden's going to come?
Hello.
Hello, hello. So do you have snow yet?
Yeah.
Yes. Well, that's good. You need the precipitation.
Yeah.
Are you in the library now?
Yeah, we're just over in the pods in the library.
Yeah, good. It was better when the class had the bigger room.
Yeah, probably.
You had 2 rooms and you'd go into the second room all the time.
Yeah.
Hi. This is Jackson Hole High School. They already have snow. You would like it there, Glenn.
I would like it.
It's the most beautiful place in the world, I think.
It is very pretty.
It is really beautiful. It was too bad what happened to the Bear 399.
Yeah.
What a shame.
There were a couple people who considered, I think it was teachers actually considered going as one as a bear and another one as a car.
Oh.
Yeah.
Yeah, one of our most famous bears in the area got killed by a car.
Oh, I'm sorry to hear that.
Yeah. It's the Grand Tetons, but the bear was actually outside the Tetons, a little 27-year-old. Yeah.
She'd been around quite a while.
Yeah.
They're out plowing my driveway right now.
Oh my goodness, you got snow too?
Of course. We're a lot higher than Jackson Hole is. Sorry to say, guys.
I didn't realize that. It's cold here, but it's sunny and no precipitation.
Yeah.
So we're ready when you are.
Yep.
They had to move to the library. They only have a small classroom now. They used to have 2 rooms, but their other room got taken over, I think, by a Spanish teacher.
Yes.
That's correct.
And then after that, we got Glenell, and we're done for today.
Alrighty.
You should be able to share your screen.
Yep.
If you want to. That's up to you.
Like sharing the screen is a bit important. Why is it all just errors?
Oh my god. That's interesting.
Why? Oh. Why do you need no. Sorry, it wants permissions.
Oh, that's so frustrating.
Wait, we need to quit in real pitch.
We might need to quit and rejoin. Sorry. Let's try not doing that. Hey, it works.
It works. Okay.
Oh,
Yep.
good.
Alrighty.
Oh, yes, we got it.
Right. So, Holden just, I bet he forgot.
You
Probably
changed the acronym.
Yes, we just changed the acronym. We needed a name like 5 minutes. And looked over at the poster and good enough. So
Put it on slideshow, can you?
yes,
Just hit.
that is smart.
There you go.
So unused to Zoom. It's been so long.
Yeah.
All right, so our team is Team Hunzi, high school students united with NASA to separate ice. I'm Great Duncan. This is and Holden Leosh is not here right now. We are from Jacksonville High School, and we are under Keen Anderson as our teacher. Why?
Just like
yeah. So our project was the separating ice from Lunar Regolith project. We're aiming to get an effective solution for it, and harvesting ice is a essential thing that we are going to need if we're planning to establish more permanent things on the moon, because we can get both water and also fuel through hydrogen and oxygen electrolysis. And the goal is to increase concentration by 10 to 20% at least. Well,
yeah. And some of the design criteria constraints are the cable system. We need to make it efficient. Also, they must withstand extreme temperatures. I believe it goes up to negative.
It is plus or minus 250.
Yeah, and down in the craters. So
down in the craters, yeah, it is negative 400, I believe.
Yeah, something like that. Effective heat management. It shouldn't get too hot, because if it does, it won't work. The ice would melt, and
technically it would sublimate. Technically,
yeah, it would just pass the liquid state. We need to adapt to lunar gravity. That's something we can.
Yeah, it's something we didn't initially think about, but we need to, because due to lower gravity, many sort of solutions might be different, but we can't really test for that much.
Yeah, and then the particles are actually really similar, so vibration is the best method that we could use. And then the sample collections, we could either have a batch process or a ongoing process that
continues.
Yeah, a continuous process that just keeps going. And we need to avoid air-based methods. I don't think that we could use any, but
yeah, it wouldn't really work. There isn't enough atmosphere to use air-based, and also we tried to look for fluids, but we couldn't find any. Why do we want to actually go through and look at these? Yes, probably.
Do we? Yeah,
probably.
Yeah, that's element A.
Yeah, this is just our initial statement. So Team Hunzi, high school students united with NASA to separate ice, is working to solve the ice from regolith problem presented by NASA. The team will be working throughout the year to develop solutions using a mix of materials provided by NASA and our own external research. Need for materials on the moon is a concern for possible emissions due to the cost associated with launching large payloads. The ability to harvest ice from the moon reduce the need to send water and could allow for on-site fuel production.
Hey guys, do you guys have a prototype for us to see? Any kind of testing you've done?
We do not currently have a physical prototype. We are focusing more so on trying to get a viable source of vibrations for our testing. We are currently working on that. We've been trying to adapt speakers into a reliable source of vibration. The only problem we've been running into is our frequency driver does not provide much power, and we currently have an amp on order to help to try and fix that problem.
Yeah, we don't have enough throw to actually get anything. So
Yeah, we have a 15-inch cone from a sub that we've been trying to run, but it just requires too much power. So we can get the frequency out of it, but we can't really get much volume, which is what we want. And that's what we've been trying to fix.
Okay. Have you set up anything so that you can see if what you've got does what you need, does something? I mean, do you have like a bowl that you can put dirt and plastic in and see how it behaves with the vibration that you get off your woofer?
Yes, we have tried to do that, but the issue was we weren't getting enough vibration for it to actually move around the substitute. We actually have from a prior project, we have some Lunar Regolith simulant that was left over from a previous HUNCH project.
Okay.
Right region and everything.
Okay.
But we poured some in and it didn't move. We didn't have enough vibrations to get it to.
Okay. Well, and a 15-inch subwoofer is interesting, but it's not necessary to have one that big. It might be that if you just got a smaller one, you could power it easier.
We do have other speakers that we've tried as well, and the issue is still we have not gotten enough throw out of them.
Okay.
So we're working on getting in there right now.
Yeah, we have it on order.
Yeah, to get the throw kind of to get the actual substance to
Okay. And what kind of bowl are you using or container for your regolith and plastic?
So currently we just tried it in the 15-inch subwoofer and we just put the regolith directly into the cone itself. But eventually we are planning to effectively just get an aluminum roasting pan and use that as our base.
And I think that's a good beginning as well. Now the shape of it can also be important. Whether you make it like the shape of a hopper so that it's kind of conical and all of some stuff would go at the bottom. Do you have some thoughts on that?
Yeah, different shapes could be very useful. Like if we had conical where you'd have your heavy at the bottom and you have a thin layer of your ice at the top, likely. Probably also a cylinder where you could have less surface area. You could have actual, for the columns, that you could have a thicker layer of concentrated material that would be easier to skim off the concentrate as opposed to a thinner layer where you'd have to be very delicate with your collection.
Sure. Okay. All right. Now, this is one link you had. What else did you have there for us?
some of the research we did on prototypes and just go.
Oh yeah, let's see what kind of thoughts you had for this.
So we have a couple different. Oh God, it's still in it. Remove it. Go and remove it.
Oh, which one?
Which one do you think? You know exactly which one. Sorry, there's one in here that we put in like as half a joke. Yeah. Sorry, we're high schoolers. We're not the best at being professional at all times. So we have a couple solutions.
It's not in there.
Okay, describe what you got at the bottom there. What is that?
This here at the bottom?
Yeah.
This is a diagram from a patent for separating. It's a system for extracting water from Lunar Regolith. It is a patent for exactly what we're looking for. And
is it doing what? Are they doing a similar process as we are?
Yeah,
I believe so.
Are they using vibration?
Well,
it's
They use
using
several
a couple different. So it's the first stage in here is. Oh, actually, no, that's the last stage. Interesting. Or is it?
No.
It's so they use actually multiple different situations. They one that is very interesting is they charge the regolith mix with static electricity, and then they attempt to pull the ice out with a magnet after it's been.
Oh,
you finally showed up.
I'm not
track.
sure how magnetic ice is.
No,
Yeah,
the
but
regular
the thing is charge it with static so that it will be attracted. This is Holden.
Static electricity is also not attracted to magnetic. So
Really?
now, however, there
just
is.
ask, can you just, what is a tribocharger?
A turbocharger, that is something that we had to look up as well. That is to charge it with static, if I remember.
Oh, okay. Okay.
Yes. I thought it was a misspelling of turbocharger at first.
Me too. Actually.
Okay.
So who did this pattern? Do you know whose pattern is this?
Metzger.
Philip Metzger.
Yeah.
So.
And
oh yeah, Philip.
You know him, Dave? Oh, there it is. Philip Metzger. Did you look him up?
Yeah, we looked it up. We were doing some research on what we could do, trying to find inspiration, and we came across this, and we were wondering. So we did some research on it, and we found out that the turbocharger was basically charging it with static.
Yes.
Okay.
Yeah.
Okay. I'm skeptical of what this person has patented.
Yeah,
it seems like they spent a lot more money on it than what it's worth, is my opinion.
Yeah.
Yes.
Okay. What else you got?
Where? That looks about right. All right. That one was also you, Ricardo, I believe.
Oh, that one?
Yes.
That one's basically putting water on it. I don't think it was
down a little bit.
Something, yeah, it was something. Scroll down a little bit. It was something we found out. It is not specifically to separate the regolith from the ice, but other stuff. And we were wondering if it could work. So we did some research on it, and we would need to isolate the water so the ice would rise up and the regolith would fall down. We're not pretty sure that would work very well. We actually had constraints.
Yeah.
I think it's too much energy.
Yeah.
Yeah. And also trying to find a liquid that can stay liquid at those temperatures while also being lighter than ice is very hard. We do.
Well, helium would work, but that would be really expensive and difficult.
Separating it with helium?
Yeah.
Interesting. I believe this mechanism relies on having a liquid that is in between the densities of the two things you are wanting to separate. So we would need to have a liquid with a density around 1. So we need a liquid about the density of water, because the ice is a density of 0.9 grams per centimeters cubed. And the regolith is about 1.1 or 1.2. So we need some liquid in that range. And I believe there are a couple that
water.
Okay. So instead of continuing on about things that we're not going to do, let's go back to what you guys can do. So, do you guys have those sanders, like a handheld sander that you plug it in and it has some vibration to it? Have you tried using that as your vibration mechanism?
We haven't. We didn't even think about that. We were thinking we were trying to focus more so on sources of vibration through linear movement, not rotational necessarily. We have a couple more ideas in this.
Vibrating plate.
Yeah.
What's this?
Yeah. This is just a patent for separating grains, I believe, that wood chip sorting. Yeah. This one, I believe, is not necessarily very viable. I believe that one is relying on optical. Yep. Yes.
Okay. Well, yeah, this is all interesting research, but I think that they're going for things that are not necessarily a good idea.
Yeah, this all strikes me as being very esoteric in nature. What right now is your primary method of separation?
Currently, we are going towards a method where we use a speaker style vibrator to vibrate a pan, essentially.
Should we bring out the speaker?
If you would like to go and grab the speaker.
I'm down. I
Let
can
me
grab.
give another suggestion. I think speakers are a great way to go. But if you're having difficulty with that, you might just try some. Do you guys have like Vex motors or any kind of motors that you've got on campus that are available?
Yes.
And so if I take just a Vex motor, and so I've got the axle coming off, if you just put something on the end that is off
Like a
off
cam.
center, you're gonna get vibrations. And if you can control the speed of your motor when it's spinning like that, increase or to decrease, you're gonna get plenty of vibration.
Yep.
And so it doesn't have to be something complicated, and you shouldn't have to order a bunch of things. I think that you can get some decent vibrations just out of something that rotates and is off center balanced, so that you'll get plenty of vibration off of it. Does that make sense?
Yes.
And if you've got some of these different motors, I think you probably got some really good motor controllers available as well. And so you can get a lot of different speeds off of these motors. Is that okay?
Yeah.
Yes.
And then I think it'll get you started really quickly on how to, I mean, depending on what kind of bowl or container or whatever that you want to work with, I think you can get started pretty quick on that. What kind of have you started making your ice simulant yet?
Ice what?
Your plastic parts. What kind of plastic pieces were you going to put in your regolith?
We're already gonna use ABS.
We were going to
3D
use
printed.
ABS.
Yeah. 3D
Okay.
printed.
Were you just going to trim it off of like a filament?
We're gonna sand it, I believe, right?
Yes.
Yeah.
In the prompt for this project, it says we should sand it with 180 grit sandpaper, I believe.
Okay. Check it again, because I've redone it since then.
Oh.
And that takes a very long time. And actually, we just got comments from a couple of other teams. They had used like a coffee grinder or something like that. So imagine if you take just like filament from a 3D printer and then stick it into like a coffee grinder and chop it up. It'll get into some really tiny pieces very quickly. Does that make sense?
Yep.
Yeah.
Yeah, don't do sanding. That's not.
I was wrong.
Yeah, don't do. And he changed it to what did you say instead? Just cutting the AP.
Yeah, just cutting it. But if you can get into, I mean, you can cut it up and get some pretty small pieces with scissors. But I think you can do it even faster if you use something like a
blender,
like a coffee grinder or blender or something like that. Okay.
Yeah.
Yep.
Yeah.
Check
And
with
you-
mom first.
Yeah.
I don't want you to get in trouble.
Yeah. And actually, you can buy, one school bought those little
The
what do
little
they
pellets.
already made. Though it sounded like they had to buy 40 pounds of it.
Okay, so wait a minute. You go over to do you guys have a Hobby Lobby in your town?
No.
Okay. Well, there might be an art supply store, and they might have some plastic pellets. And exactly what they might use them for, I don't know. But check and see what type of plastic pellets they have. And they're smaller than a pea. It'd probably take 4 of them to make a full-sized pea. And that's a very good start, and it would go much quicker than what we're talking about. Okay?
Mhm.
So
Awesome.
there's some different options for you.
Yeah.
Okay.
You might actually go to Native American store and get beets that are very tiny.
Yeah. Depends on the material too. But I guess that's a good start.
Yeah. Well,
now somebody else measured the density of corn, and they found that it was very similar.
Yep. watch the videos and you'll see different, I'll put these videos online and you'll see different suggestions on how to get that plastic
Okay.
or not get the plastic and do different things. But yeah, I remember when I visited, you had that big speaker already
Yeah.
set up. Yeah. So some downsize it would be important. But keep at it, guys. I like I am surprised there were even patterns for this already. I didn't think other people were really thinking about it, that they would make a pattern already.
Yeah, I think
really
I was not very impressed with at least the first one and maybe the second and third one too.
Well, this one is a Chinese, I think.
Yeah.
And they did use vibration.
And this is another idea.
Yeah,
Well, maybe
and
the
this one,
Chinese are smart.
yeah, and here they're using vibration also.
This is something used in like mining to separate out tailings.
Yeah,
And
well,
that's a smart thing to do.
And
yeah.
Last minute add on.
Okay.
Yeah. Good research.
I just looked up the density of corn, and it's a little bit higher than you would like. I think that I think you could probably do better with something besides corn.
Okay.
All right.
Yeah, but watch the videos. I'll put them online.
All right. Thank you.
Okay, thank you. Thank you so much. And you be careful driving in that snow.
Okay.
Yeah.
Have a wonderful afternoon. Okay.
Good job.
Bye-bye.
Keep it up.
Yep. Bye-bye. Here's Nancy joined us.
Oh.
Hi, Nancy. And we got one more school. We got Glenell. We're ready for you, Glenell.
All right.
All right. Bye.
Hello, team. Ice. This is the ice team.
Hello.
Hello.
All right. Yeah. Bye.
Bye-bye.
Bye. Yes.
Does that look good for you guys?
Yes.
Sure does.
Awesome. Good morning. We are the Glenell Ice Team, also known as the Ice Crater Extraction Team. My name is Elise Cho.
I'm Amitav Kohli.
And I'm Alex Chapin.
And our NASA HUNCH project is to separate lunar regolith from ice using vibration. On the moon, there are these permanently shadowed regions that have temperatures ranging to almost lower as negative 400 degrees Fahrenheit, and orbiters indicate that there's actually ice mixed with regolith in these craters. So this is extremely important as it costs $1.2 million per kilogram to lift into space. So if we're able to use the moon's already available resources, this will be a huge time and cost saver for NASA. And our target location is the Shackleton crater on the moon's south pole.
Yeah, so this leads us into a problem statement where NASA's Artemis mission says they'll send 4 humans to the moon in approximately 1 year. But apart from the water they take with them, they'll have no water source on the moon. However, as previously mentioned, NASA's SOFIA orbiter indicates about 400 parts per million of ice mixed with some of the lunar regolith. And this is found in the Shackleton crater, which is one of those PSRs, the permanently shadowed regions. And each kilogram costs $1.2 million to transport with SpaceX. And extracting the water in just 1 cubic meter can save over $500,000 in transport costs. So according to their project outline, the water will be used to create rocket fuel, drinking water, rehydrate the dehydrated meals, cool equipment, and more. And they anticipate establishing a permanent moon base with at least 8 people on it constantly in the next 10 years.
So in order to get a basis on how our project works and what people think about our project, we did a survey of some of our peers and associates and asked them a number of questions about our project. So the first question we asked them was, how familiar are you with the lack of water on the moon? And a lot of people responded, said they were either somewhat or very familiar with the problem. So this does show that this is a problem that needs to be solved. And then the other question we asked them is, what do they expect the water to be used for? And a lot of people thought that it would be used for drinking water, cooling components, or hygiene. But a lot of people did not think that it would be used for rocket fuel or oxygen, as it can be used.
Yeah, so and then we got into researching some of the patents. One of them was on magnetic and another was thermal drilling. We did more of them, but these kind of kept showing up in lots of our research. So the magnetic one exploits the magnetic properties of ice and regolith. Ice is diamagnetic, whereas regolith is paramagnetic, meaning ice always repels and regolith is always attracted to a magnetic field regardless of charge. And so at very low temperatures near absolute zero, these magnetic properties are amplified. And with the lower gravity of the moon, they'll also be easier to exploit these magnetic properties. Thermal drilling, on the other hand, uses friction from a drill as it goes into the regolith to almost separate the water just like that. It filters it, and that friction creates lots of heat that vaporizes the water and pressurizes it. So it can be kind of used just as is and recycles power loss, which is a big part because power is super limited over there.
Yeah, and going beyond patents, we also researched real-world applications for these concepts. So vibration was given to us by the NASA HUNCH problem statement, and we actually found this to be very advantageous through our research as we can control both the frequency and amplitude when testing. And so using vibration, this will be able to achieve the most efficient separation means when we're testing and figure out which vibration area that we're able to use to separate them the best. And then it also uses very low power usage and it's very durable as it has fewer moving components. And as Amintov explained before, the thermal drill is actually being developed by NASA currently on the Trident 1 lunar drill, a part of the Polar Resource Ice mining experiment. And that's set to launch in around 2025. And so this drill is really cool as it can separate both the regolith and the ice, and then also condense the ice into vapor to be used.
So now we took some of our patents that we had researched and discovered things about, and we then ranked them based on number of specifications that would make them more or less useful to NASA. So we ranked them on number of specifications like power usage, simplicity, has it been like proven on Earth, and then how much water does it produce, how much power does it use? And the one that came out on top was using vibration with a size-based lunar separation coming in second, and then in third, the drilling.
Then after we created our similar solution matrix, we were then able to develop our design specifications. So our criteria includes that we need to use vibration and also achieve a concentration of simulated ice to at least 20%. And this will allow us to see if we're able to achieve that and have a measurable outcome when testing. Some of our constraints is that we have a budget of approximately $100 to spend within the next 6 months. And we also need to be able to create a device that can withstand very low temperatures in those PSRs on the moon. And our testing densities for the ice is around 1 gram per cubic centimeter, and our regolith is around 1.5 grams per cubic centimeter.
Yeah, so we then took these design specifications and researched accordingly. We continued research on vibration and magnetics. So with vibration, we can use piezo discs to create vibration, which have a very large frequency range, but a small amplitude range, whereas speaker drivers have a larger amplitude range, but smaller frequency range. We also saw that copper, because we need to stay in that super low temperature, negative 400 degrees Fahrenheit, copper and an alloy copper nickel can withstand temperatures below negative 400 degrees Fahrenheit, around negative 415. So around absolute zero, which is the temperatures we're looking at. And also on the top right, you can see an image of how the vibration can be implemented with the particles on flat plate, and the vibration is angled, and that way the particles can actually move through across the plane. Magnets, on the other hand, like I mentioned earlier, you are experimenting with paramagnetism and diamagnetism. So they should inherently separate in the presence of a strong magnetic field. However, the theory behind magnets tends to break down, especially on the unknown conditions of the PSRs. So we can't really test this on Earth, which is why we can't move forward with it right now. But it was one really good idea that we did find.
So then we took all of our sketches and ideas for how we can solve this problem we developed, and we put them into our decision matrix and ranked them again based on the specifications that would make the project useful to NASA. So the two we came up with that were the most helpful was a vibration on a flat plate, where the less dense particles would move both to the outside and very inside of the plate, leaving a ring of the more dense particles around it. And the other one we used was, like Amtav said, the angled vibratory movement, which would move the less dense particles further along a plate than the denser particles.
Yes, and then moving forward from our decision matrix, we then combine these two ideas into annotated sketches. So on the left, you will see the angled vibratory movement and how the lighter particles can travel up the ramp and into a collection container for future use. And on the right is the square plate on top of a vibration motor that will allow the lighter particles to travel to the middle of the plate.
So this led us to our CAD model. We're using a 15-inch subwoofer, but we can also change this. We went from smaller, like a 3-inch speaker, to a 15-inch subwoofer just because we get that larger amplitude range. And we can see the angled ramp. And this is on a stand that can adjust so we can test for different angles. And then also we have another plate afterwards because we have 1 degree of separation, then the other degree adds another way of separating it so that we have an even greater concentration of ice, where the less dense particles will go to the middle of the second plate, and then a small door can drop down to let them out.
So what are we going to do moving forward? We're going to continue looking into using vibration in both these methods, both the the angled horizontal movement and the flat plate separate by density. So we're going to continue to test a number of different amplitudes and frequencies with our speaker, and we're going to continue to create our prototype system. So here we have a video of the in use. So as you can see, we used a lighter pepper, and then we use a heavier. That is the ABS plastic that we cut off of the filament. And as you can see, the lighter pepper, because we couldn't find any concrete powder, the lighter pepper moves off the end of the vibration plate and is collected in our jar there at the end, while the heavier materials remain behind.
The one thing we did make sure to keep in this is the difference of density between them. They still have about half a gram per cubic centimeter difference. So it's just a matter of increasing or decreasing the frequency to find the one that works with the actual stimulant. Thank you so much. And if we have any questions.
Okay, I'm a little confused. You had pepper, but you couldn't find dirt.
So the dirt particles were really big, and we didn't want to, because the size shouldn't be the separation factor. So we wanted to keep the constant density between them. So we chose density over size because the main point of it was like size is really similar, so we didn't want that.
Okay, and that's fine. But I mean, so one of the things that you're going to have some difficulty with is that there is going to be gravel in there, right? Yep. So not only are you going to be dealing with very fine particles of lunar regolith, we're also going to have some larger particles, at least the size of, peas and maybe quarters and things like that. Does that make sense?
Yeah.
And so a bag of concrete shouldn't cost you more than about $3. And if you can get a smaller bag, it doesn't hurt my feelings at all. And so, so right now you've got some ABS plastic. Is that what you have?
Yeah.
Okay. And just know that ABS plastic will work. But of course, if you can get something that's closer to the density of ice, you'll get even more separation. Okay.
Mm-hmm. Mm-hmm.
Okay, and it looks, so you've already gotten your speakers to vibrate for you and be able to give you some kind of separation. That's very exciting.
And that was, if we go back a little bit, that was because the angle, just because it pushes it, the speaker pushes a vibration in an angle, whereas the plate just acts as a medium where that vibration is transported.
Okay, now, and do you have an idea of what you're going to do with the regolith that does not shift out? How do you get rid of the regolith while you are moving the ice particles?
So we were thinking of like a trapdoor at the back. So periodically you'll have like a number of, just our raw soil goes in, and then we'll have all of the ice particles flow off the end. And then periodically on some time delay, we'll have a trapdoor at the back open, and all the dust the dust or rocks that were not light enough to go off the end and weren't ice will fall out the back.
Yeah, and then as we continue developing this, we want to make it, one of the main things was making it like a continuous process rather than batch process, so it has to stop and reset. So the continuous process we just have to kind of think more through it, how to actually make it continuous. But that will come as we finalize most of the frequencies and all of that.
Sounds good. Dave, you got any thoughts?
So, can you describe how you're adjusting the frequency? You have speakers. Do you have something that you can control the power input, or you can adjust the hertz on these speakers?
Yeah, so we're using a stereo amplifier. I don't know if you guys can see that. It's essentially just
perfect.
a stereo amplifier that we then plug into our laptops, and we use a waveform generator to create all different frequencies of sound, and then that's just played through the speaker.
Very good. Okay. That's awesome.
Can you stop sharing and show us that you're using?
Yeah.
There's that.
And then here's the subwoofer with the angle plate.
Very good. Okay.
Okay.
Now, so here I see that you've got a cardboard piece on there, which is perfectly fine for the beginning. Do you have a plan for what other materials you might want to try?
Yeah, so we mentioned in the presentation we wanted to try copper just because that's the most realistic. It can withstand the super low negative 415 degrees temperature. And it keeps one thing we have to pay attention to when we're vibrating is the material stiffness because we don't want the ends because the vibration goes to the middle of the material. And so we don't want the ends of the material kind of like waving.
Agreed.
So we wanted to keep the material stiff, and that's what copper does. So right now on the bottom, we actually don't have cardboard. We have a polycarbonate sheet, which is still flexible, but much less flexible than cardboard.
Okay.
Very good. And the shape of it is also going to prove to be interesting. And exactly which things are going to work the best, I don't know. But I like what you've got started here. Good job, team.
Thank you.
I do too.
Flo, do you have any thoughts?
Well, just that when you keep talking about frequency and amplitude, I keep thinking about sine curves. So that's what tells you the frequency and amplitude, right? Of anything. So if you come across a good frequency and amplitude, you could demonstrate it, document it with the sine curve that fits their qualifications. Because
during our testing, we actually recorded a data sheet with it, and our best separation frequency was around 73 hertz. So that's like in the video, that's what's portrayed.
So that's important information that you need to let us know when you're doing that. So cool.
Yeah.
Well, so I was a math teacher, so of course I think about sine curves.
I'm
Nancy,
interested in what Nancy has to say.
Yeah, Nancy,
No,
what do you
yeah,
have to say?
no, I really like what they're doing, and I love their design and the drawing and everything. And I think they're on a good path because I know some of the other students have been trying to use a speaker. Not everyone has had success, and it sounds like you guys are getting some good data. So good to see that. So keep it up.
Yeah, and your PowerPoint was awesome too. Your presentation, everyone talked. It was really cool. Thank you so much. Do you have any questions for us?
So you said a group kind of bought like pellets. Like, do you know any more details about that? Because as we were cutting them, it's just it's so time consuming. So tedious.
Yeah, one other team said it took them 8 hours to make like a quarter of a cup of that stuff. So the pellets, that was the New Jersey team that they bought pellets. So I can find you the information about that. But they actually had really good pellets that were good size and everything already made.
Well, the pellets were kind of big. And so if you can get pellets and then grind them down somehow, kind of like, using a coffee grinder or a blender or something like that, I think it'll work okay.
The pellets were 3 millimeters, they said.
Oh, that's right. They said 3 millimeters.
And that sounds really homogeneous to me. I think it's a good starting point.
Yeah,
it is a good start.
My two comments are number one, as Glenn was saying, go to a local hardware store, an Ace Hardware or Home Depot, Lowe's, any of those places, and buy a bag of Portland cement. Right? That's your regolith. Another thought is we've had teams working on different projects that have actually used paper shredders to grind up like ABS, PLA, both.
That's a great answer.
They do work. Right now, you're probably going to be dedicating that shredder to your purpose. I don't know that it's going to go back and be very effective as a paper shredder, but that's another way to think about doing that.
So
yeah, we don't want you to spend hours cutting up.
The thing about the something like a paper shredder, you don't want this to be too homogeneous, right? I cannot imagine that all these crystals are going to be of the same size, et cetera, right? They're going to vary significantly. So you want some that is almost as finely ground as the regolith itself, but you need bigger chunks, et cetera. So you just need to find some way in a blender, like I say, a shredder, anything like that you can grind up some plastic.
So,
Okay, yeah, thanks.
and if you start with like 3D printing filament, that'll make it much easier for whatever you're grinding it in. Does that make sense?
Yeah.
So
you also
we-
have a lot of residue. You know, if you guys are doing a lot of 3D printing, you have a lot of extra stuff left over, right? And that's a great source. You can just dump that into something that you can grind it up with.
That's a smart idea. The scaffolding that you have to scrape off. Use that.
It's recycling. Oh my gosh.
It's recycling. Yeah. But I do want you to wear a mask when you're doing with the cement and grinding the plastic. Oh, what do you have there, Mr. Gershner?
It's been in the back of the truck for about a week. It's just 60 pounds, but they can't carry it. Yeah, it's a 60-pound bag of saccharin. They just can't carry it.
We can carry it.
Yeah. All right, well, that
but
is
we
good.
did. We
Go
did
ahead.
actually look at buying like injection molding pellets. They were just, like you said, too big.
Yeah, just look for a way to cut them down some. I think it'll be good. Okay. And they're ABS or what are they?
ABS, yeah.
Okay. Yeah. No, I think that those would work fine if you can just cut them down a little bit. But it would also work just to show that they will rise through your regolith with the vibration. Okay. Good job, team.
Thank you.
All right, thank you.
All right, thank you. And any other questions, you can always send them to me, and I'll send them on to whoever I need to. Thank you so much.
Thank
You
you.
guys have a wonderful week. Great PowerPoint too, by the way. Really
Right.
nicely done. And
We'll see
your
you soon.
presentation. All right, that's it for today. So
All
we
right,
are
very
good.